So let's discuss a topic from GATE 2021 physics. This is related to the intensity of diffraction peaks and X-ray diffraction. So as shown in the figure, X-ray diffraction pattern is obtained from a diatomic chain of atoms P and Q. So here we can see in the figure, this is atom P and this is atom Q. So it is a diatomic one, two different atoms, uh, and here we are obtaining the X-ray diffraction pattern. So the diffraction condition is given by A cos theta is equals to n lambda, and where n is the order of the diffraction peak and A is the lattice constant and lambda is the wavelength of X-rays. So assume that the atomic form factors and resolution of this instrument do not depend on theta, then the intensity of the diffraction peaks is. So we need to provide information on how the intensity of diffraction peaks would be based on the diagram. So in diffraction pattern, how it would be. So here we can see, if we clearly observe the diagram, so the distance between the two atoms is a by 2. So this is also a by 2. The distance between two similar atoms is a. So here we can see. So that is mentioning. And another important thing is, so the rays are falling in this manner and they are getting scattered like this. So here there is an angle between, so this is suppose x-axis we imagine. So let this be some x-axis. So based on the diagram, let us suppose this is some x-axis like that. So the rays are coming in this direction and they are leaving, getting scattered in this direction. The scattered rays are making an angle theta with the x-axis. So here that is mentioning everything of this everything. And now what we are supposed to do is, so let's see, and for this what we do is, let us first provide the give position coordinates for all these four atoms. So here, because e power I k dot r, so electric field intensity, electric field formula for electric field amplitude could be written as E is also E naught into e power I k dot r. That means r is nothing but position vector. So first of all we need to have an idea of the position vectors, that is which atom is at which position. So for this, so we will take an atom from here to here as given in the diagram. So here also the rays would be coming, they would be getting scattered, and from here also this atom also would scatter this light. So like this, bit by bit it would happen. So let us take for simplicity these four atoms for now. So with the help of these four atoms, so let us start counting from here. So at this position, the x coordinate is x, let us suppose, and from distance between these two is nothing but a by 2. So because here clear mentioning of a by 2, so here the position coordinate would become x plus a by 2 for this atom. So let us give a numbering: first atom, second, third, fourth, like that. This is fourth atom. So we'll take for just for four atoms, and here the numbering would be x plus a, because from here to here the distance is a. So it is nothing but x plus a, and here it is nothing but x plus 3a by 2. That means this a plus a by 2 is nothing but 3a by 2. So for that reason, so here we would have x plus 3a by 2. So here x plus 3a by 2. These are the position coordinates. So as we have assumed along the x-axis, so for that reason, so these are the position coordinates for the different atoms. So how the scattering would be, so the resultant scattered electric field would be like this. So for this is scattering produced by the first atom. So actually here, this is the incident beam, E naught into e power I k dot x k dot at the xth position. So this is scattered by this first atom. So here the first atom is this sky blue one. So the scattering produced by this atom is represented with a constant A, and the scattering produced by this green atoms is represented with a constant B. So the because each atom produces its own scattering, so hence we have used two different constants for two different atoms because it is a diatomic molecule. So now here if we see, so this is scattering produced by first atom, scattered beam. So here we can see the scattered beam. So this scattered beam is represented with this formula, E naught into e power I k dot k naught x into A, because our the position vector for this atom is x. So that's why we have taken x and A for that particular atom. The scattering factor we have taken as A. Next to that is this. So this E naught into B. So E naught, the scattering produced by next atom, that is B, e power I k dot r. So actually the formula is e power I k dot r. So how we can write this k dot r is, that is nothing but a dot b, that is k dot r is nothing but magnitude of k into magnitude of r cos theta. Cos theta. So here we can see this is nothing but k dot r, that is nothing but magnitude of k. Magnitude of k is k naught and magnitude of r is x plus a, because the distance from here to here is x plus a. This total distance, this atom is at somewhere in the crystal lattice, so at a distance x. So next atom x plus a by 2, next atom x plus a. So that is nothing but magnitude. So that is nothing but k naught into magnitude is x plus a, magnitude of r, and cos theta. Theta is the angle between them. So here from the diagram, if we see, this is the scattered light. This is the direction of the scattered light. So here you can see, and this is the direction of the x-axis. Like this. So the angle between them is nothing but theta, that is nothing but position vector. Position vectors are taken in this direction. Here scattering is in this direction, so hence the angle between the both of them is nothing but this cos theta, hence cos theta. So in the similar fashion like that only for the next atom, that is third atom. So here we have seen this for this scattering produced this by this third atom. So this is same as this previous atom, that is first atom, same as that first atom. So hence here we are having A, and E naught is the amplitude of falling electric field, and again here k dot r. So it is at a position x plus A, third atom is. So that's why k naught into x plus A cos theta. Here magnitude of k is nothing but k naught. So in the similar fashion, E naught into B, e power I k naught into x plus 3 by 2a cos theta. So here x plus 3a by 2 cos theta. So here you can see x plus 3a by 2. So it is at the position of x plus 3a by 2 from the starting. So that's why x plus 3 by 2a cos theta. Magnitude of k is nothing but k naught, that is depending on the incident light, and this is cos theta angle between them. So for the four atoms we are now we have mentioned four possible scatterings. So now from each and every term we can see e power I k naught x, e naught into e power I k naught x, that is a power m plus n is nothing but a power m into n. So this could be written as e power I k naught x into e power I k naught a by 2 cos theta, like that. So here also, so we just need to take e naught into e power I k naught x, e naught into e power I k naught into x. So we just need to take it out. This is common everywhere. So here what would remain is a from here, and here from here b into e power I a by 2 cos theta, and k naught is nothing but 2 pi by lambda. K naught is nothing but wave number. Wave number is nothing but 2 pi by lambda. That depends on the wavelength of the incident light. That is number of waves in 1 centimeter. So in 1 centimeter, that is decided by the wavelength. So from here to here, suppose it is 1 centimeter means, so how many waves would fit up? So that is nothing but wave number. So for that formula is nothing but 2 pi by lambda. So that one we have substituted here. So in the place of k naught, 2 pi by lambda. And next here what would remain is a naught. A would be remaining, and a cos theta. So a cos theta, k naught is nothing but here if it is multiplied with k naught, what would remain is e power I 2 pi by lambda. So as this e power I k naught x is taken out, so it has been taken out, here you can see. So like that. And in the next step, so in this step e power I k naught x in b, if they are taken, what will remain is this if they are taken, what will remain is this b and this 3 by 2 a cos theta, e power I k naught into 3 by 2 cos theta. So that one we have mentioned here. So finally we would have this form. And now this diffraction condition had been given in the question. A cos theta is equals to n lambda. So a cos theta is equals to n lambda, condition for diffraction. So next what we will do is, so here we can see a cos theta, here 2 would get cancelled, a cos theta by lambda. So a cos theta by lambda could be written as n. So in each and every case, a cos theta by lambda is replaced with n, a cos theta by lambda. Here also a cos theta by lambda is replaced with n. So hence we are having e power I 2 pi n. And here also we are having e power I pi n. And here also 2 would get cancelled here, and what would remain is a cos theta by lambda. So 3, that is 3 into pi n. Yeah. So here 2 would get cancelled, and here 3 pi, here you can see 3 pi n is nothing but a cos theta by lambda, a cos theta divided by lambda. So in the place of that, hence we are having e power I 3 pi n. So based on this formula, all these terms would be shifted to in the form of n's. So like this we can just shift it out, and this is as usual, it will remain as usual. And next thing is, so this is the final thing we are achieved, that is E. So now intensity is nothing but amplitude square. Intensity is of light or diffraction pattern is directly proportional to amplitude square. That is nothing but amplitude of electric field vector. So amplitude is nothing but magnitude of E. Amplitude square, magnitude of E whole square. That is magnitude of E whole square could be written as, because it is in the form of a complex. It is because e power I n pi like that is there. So for complex numbers, magnitude is nothing but E into E star. That particular complex number multiply with its complex conjugate, we would get amplitude square. So hence now what we have to do is, I is directly proportional to, so this is E into E star, that means E naught into E naught square, and here this is nothing but E naught, and E naught star is nothing but in the place of I we need to replace with minus I. So here I is there, it has been replaced with minus I, and in the same fashion here also I is there, that has been replaced with minus I, and here also I is there, that has been replaced with minus I. So just that is nothing but complex conjugate. So I replace with minus I. So now what we need to do is, so this is nothing but E star into E. So this is E, and this is its complex conjugate, and E naught is real one. So E naught square we are getting doing products. So finally Now we just need to multiply all these terms. So what we need to do is just keep on multiplying. So from first of all, e naught square is remaining as usual. This a into a is nothing but a square. Like that, this a into b e power minus I n pi is nothing but this term, ab e power minus I n pi. Like that only, a into this term is nothing but a square e power minus I 2 n pi. In the same way, a into this term, that is ab into e power minus I 3 n pi. So like this we are having. In the same fashion, this one into this one is nothing but ab into e power I n pi. So here you can see, and this one into this one is nothing but b square into e power 0. That is e power x into e power minus x, that is nothing but e power 0. So hence only b square would be remaining. So like that only this term multiplied with this term. So here b is there, here a is there. So ab and I n pi minus 2 pi n, that is nothing but 1 minus 2, like minus 1. So minus I n pi. And next thing is, and this term b into b is there, so b square e power minus, here minus 3 is there, here plus 1 is there, minus 3 plus 1 is nothing but minus 2. So this one we are having. And next thing is this one multiply with this one, a square into e power I 2 pi n. So this one we are having. And this term multiply with this one, ab e power 2 minus 1 is nothing but plus 1. So ab e power I pi n. And this term multiply with this one, a into a is nothing but a square e power I 2 pi n into e power minus 2 pi n is nothing but e power 0 1, that is a square. So like that, this term multiply with this term is nothing but ab e power minus I pi n. So minus 3 pi n plus 2 pi n is nothing but minus I pi n. So like this we are having. And next, b into a is nothing but ab e power I 3 pi n. So this term we are having. The same fashion, this b into this term, so this both multiplied, b square 3 minus 1 2, and this both a, here a is there, b is there, so ab, so 3 minus 2 1. And next finally, this both b into b square e power I 3 pi n minus 3 pi n, 3 minus 3 0, e power 0. So finally these many terms we have got. And now we just need to separate out each terms. So here for that, so here we can see there is e naught square, but here 2 e naught square is there. So why means because of simplification. So here one a square is there, and here another a square is there. So 2a square, hence 2 into a square, 2 has been taken out as common. In the same fashion, here one b square is there, here another b square is there. So 2 b squares. So like that we are having. And next, and here if we see, this is ab e power minus I pi n, ab terms if we take, and here ab into cos n pi terms, ab and cos n pi terms, ab e power I n pi, here another, and here another one, and only ab I pi n, and here another one, and here another one. So in total we are having 6 terms. So 6 terms we are having. So all these 3, nothing but 3ab into e power I pi n, and remaining 3ab e power minus I pi n. And we know that, so that is nothing but ab has been taken on common, e power I theta plus e power minus I theta. So that is e power I theta plus e power minus I theta is nothing but equal to 2 cos theta, because e power I theta is nothing but cos theta plus I sin theta. So for this reason you would have 2 cos theta. So hence here we are having 3ab cos n pi. That means 2 cos theta, and here we are having these terms for the 3 times. So it is repeating for the 3 times. So 3 2s are 6 we would have. So hence this 3 and this 2. 3 2s are 6. So like that we are having. So hence we would get this term from that formula, by using that formula. And next thing is what we need to look at is here a square plus b square, this term in a similar fashion. So here a square uh, and e power minus I 2 pi n, here also a square e power I 2 pi n, here b square I e power I 2 pi n, and next so b square e power minus I 2 pi n. So like that. So for finally we are having like this terms, that is, so a square has to be taken as common, and so if we add this both, a square plus a square e power I 2 pi n, a square has to be taken on e power I theta plus e power minus I theta, that is nothing but 2 cos theta. So 2 into a square, so 2 into a square. The similar fashion adding this both, so 2 b square we would get, so b square into 2. So like that. And next thing is finally cos 3 pi n terms with ab. So ab e power minus 3 I pi and ab e power I 3 pi n. So here ab has to be taken common, then e power I theta plus e power minus I theta. So based on that formula, 2 cos theta, so 2 into cos 3 pi n. So this is the entire intensity we would have finally based on the calculation. And now what we need to look at is what happens if n is odd and if n is even. So if when n is odd, what happens is cos n pi or cos 3 pi n. That means we know that cos n pi, that is cos pi, 1 into pi is cos pi, cos 3 pi this, so like that terms. So all of them would be minus 1 because it would be in second quadrant. Second quadrant. So second quadrant, like that you would be having terms, and second and third quadrants like that. So like this we are having minus 1. So now what we need to do is, in the place of cos n pi we need to replace with minus 1. So minus 3ab minus ab, so that is nothing but minus 4ab. And here cos, if n is odd also, here 3 2s are 6, 1 2s are, sorry, 3 2s are 6, 1 2s are 1, sorry, 1 2, sorry, 1 2s are 2, 3 2s are 6, and 5 2s are 10. So whatever it get multiplied, we would get some even number into pi. Even number into pi is always a positive one. So here we would get plus a square plus b square. So here already one a square plus b square, so they both put together, so 2 into a square plus b square minus 4ab. So when n is odd, the same fashion when n is even, so when n is even, this all of them would be even, so this term also would be even multiplied with even. And here 2 pi, 2 3s are 6, 6 pi, so all of them would be even. So this is plus 3ab, this is also plus ab. So 3 plus 3ab plus ab is nothing but plus 4ab, and this a plus b and this both. So this also be like this. So cos a square plus b square, a square plus b square, this both added together, again we would have cos the this cos 0 is also 1, so 2 into a square plus b square. So like this is the calculation. And finally here we can see that, so here in general this is how the form. So if we consider this entire thing has some x, this entire thing has y, so this is of the form x minus 5. So and this is of the form x plus 5. So we know that x plus y is greater than x minus y. So I even is always greater than I odd. So I even greater than I odd. So because of this reason, so the option would be uh, lower for odd values of n when compared to even values of n. So because for odd values of n we can see it is x minus y for odd, and for even x plus y. So hence the option is lower for odd values of n and when compared to even values of n. So this is the solution for this problem. So thank you.